Hello and good day. I'm Greg Eva, working for PTC, part of the Digital Thread Architecture Center of Excellence. Today, we're going to do a knowledge sharing session on JFR and JMC, Java Flight Recorder, and JDK Mission Control for those who are not familiar. First, some background context. This is actually a topic that I've been wanting to do a sharing on for a couple of years. Actually, I've done already one internally, but for those of you who have seen other videos of mine or who know me, often working on things like troubleshooting, debugging, potentially on distributed systems, oftentimes on performance and bottlenecks. And JFR is something that I had heard about a couple of years ago and kind of piqued my interest. So I went digging into the subject. Not being a Java developer myself, I didn't get wind of it that way. It was more through observability channels, and discovered this magical creation of JFR, which Oracle had developed. Actually, it goes back even further than Oracle, which had been commercially sold to large Java customers, part of the commercial license for quite some time. And all of a sudden, in Java 11, it became available as a part of the Open JDK, and all of a sudden we can capture profiling and monitoring information with it. So I've been using it for a couple of years and it's extremely valuable. There's a lot of tuning capabilities to it to ensure that we can keep the overhead down. But one of the things that I really like about it is that we can do this essentially on any Java environment since Java 11 because it's enabled by default. We just have to go start a capture session with various settings, and we can take that captured setting and we can start to do some analysis on it. And this is something that is great for production scenarios. Number of situations that I've been in where we have symptoms that are presenting in a production environment, and we start to think about how do we instrument it, how do we enable logs. Maybe we have to change configuration, maybe we're going to have to restart the application. None of these things are typically possible, and one of the really nice things about JFR is we can do this on a live running environment with extremely low overhead without restarting the application, so we can start to get some diagnostics as well as profiling data that we can start to look at, and we can share that amongst our teams because it's file based, and it's open standard. So we don't have this problem of, well, technically we should have some information in our APM solution, but the people that need to be digging into it don't have access to the APM solution, or people that do have access to the APM solution don't know what they should be looking for, don't know necessarily how to use the tool. The combination of JFR and JMC, albeit there's a learning curve for sure. Extremely powerful, and has, as I say, it's been something I wanted to do a knowledge sharing session on for a couple of years. So today we're gonna dive into it. Not gonna go too deep. I have written a document actually on the topic that's quite lengthy. That at the end we'll have a quick look at the document, and that document is really intended to be, let's just say, the next step of this. But this I want to just do a sort of getting started, show you what it's all about and what we can do. So let's go. Um, Screen. There we go. We got a screen. So first of all, I've got a Java application that I'm running ThingWorks over here. It appears that I'm already even shelled into it. Just running a Docker environment where I have ThingWorks running over here. It's already started up, and I am shelled into the environment here. We're just going to have a look at the processes that are running. We can see the first process here is our Java application, and is running as process number one. Um, I'm just using PS to do that. On some systems, I'll use PID of, and you can use just PID of Java. PID of Java doesn't work on this environment for some reason, but that'll give you the process. If we've only got a single Java process, there's also the JPS tool, which comes with the JDK, and it is going to tell us the process IDs of the various Java processes. And one of the not so great things about this is we've got this one, the Bootstrap application. We've got the JQS. I really just want to know the one. For scripting purposes, that's one of the reasons I use a PID of. It's quite easy and nice to build into scripts. That way, in your runtime environment, you can just grab it. So let's, some of you are likely familiar with JStack, the usage of JStack, something along these lines. It's just going to give you the thread dumps of that Java process that I'm connected to. JCMD is a similar command where we can do things like VM flags. Here I'm just running a command, the VM flags, to get some of the flags of the running Java virtual machine. And similarly, what we're going to do is we're going to start one process. We're going to start a JFR. So JFR dot start. And you can see it started a recording. Number 2, no limit specified, using max size 250 megabytes as default. No file path has been specified, so I do have a flight recorder session that is running now with the default settings. It is called a continuous recording session because there has been no stop time defined. And something to note is this max file size. This max size is right now it's running in the heap space. So it is capturing JFR events that are being stored in the heap space. There's a ring buffer that's in there. Is going to be using this 250 megabytes as the limit. The ring buffer will overwrite that. So there are some settings we can use max size. There's also a time that we can specify as far as how much time we want to keep in that ring buffer, and you can use those two values to specify and use in your configurations. For our simple purposes, this is going to be ample. When we stop the recording, that's going to be dumped to disk, but I didn't specify a path, so I'm actually just going to go and stop it. I didn't specify a recording session, but because I've only got one, actually, even if I didn't have one, it would stop the first recording. So I would typically never really just run it like that because, especially on a production environment, as I was mentioning, this is nice to just be able to run it. If I'm going to give someone a command and say run this on a production environment, I want to make sure this is pre-vetted. I know what's going to run. I know what it's going to do, and I definitely don't want to say something along the lines of, just compose your command. So, if I'm giving a command to someone, will ensure that I know what it is and that I'm comfortable with it. So I'm going to do a JFR start. Also going to do a duration of let's just say 60 seconds. I think it's file name equals, yeah, where I am here, and then test JFR. What else do I need? That's about it. No, there's one more thing. Yeah, that'll do the trick. If I wanted to, I could do some settings. There's some default settings. I'm going to actually apply to, for the sake of expediency, profiling. Can't remember what the name is. We'll see if that's the right one. Gonna start recording. Test JFR. Great. Okay. We need to go to a different location then. /test JFR. This could be because this is actually good. This is because the user who I am is needs to have write permissions, so that whoever your Java process is running, that's the user that's going to write this file. And so, oh, great. Test JFR. Okay, great. We're going to skip some of this stuff to just get the file out and get right to the file. They've got to have the permissions to write to the file location. And if they can't write to the file location, then a couple of things are going to happen. One is going to be taken, and it will create the file in order to start it. It's if you can't create the file, it's not going to start the recording in the way that I've specified it. But the key here is that I have specified the duration. So after the 60 seconds, it's going to stop and it's going to dump that ring buffer. It's going to dump it to the file. So once your file has contents in it, then you know essentially that it has stopped and it has been dumped. Okay. Let's leave the command line and let's actually get it over into some of the analysis. So I'm going to use this was the location that file was supposed to be. It wasn't. So we're just going to use an example that I have used in the document anyway. So here I'm just running the JMC command. This is JDK Mission Control. This is version 9.1. Um, Version 9 brings along with it the flame graph, which didn't exist in version 8. There's some other things, not going to get into all the specifics, but this is the JDK Mission Control interface. We can do some things I've covered certainly in the past using JDK Mission Control as a sort of a replacement for JConsole. Some folks use JConsole to just get connected to the JVM while it's running, be able to look at the console and some things. JDK Mission Control is far more powerful. It's obviously a heavier application. The document covers doing some flight recording using this live connected over JMX connection mode. We're not going to look at that right now, I don't think. Guess we could potentially, but we're not going to do that. Not so interesting because those files are really the easiest way for us to get that one command. We get a recording started, we get access, we copy the file off of the environment, and then we're just going to bring it over here. And let me pick one. Over here, just drag and drop it in there. Obviously, you can do file open, and we immediately get this automated analysis results. So this automated analysis results, it's kind of one of those, it's not going to give you the answer to your questions, right? It's not automated in the sense of automated answers, but it's an excellent start. What it's telling us is it's got a number of rules inside of JMC that it's running an analysis on, and it's processing those rules and is coming up with a score. So here the score of 75, this is between 0 and 100. So it's giving us essentially a prioritization of the score of the particular rules that are processed. So here it's also giving us a little bit of a readout. And, this is along the lines of some of the reasons why it gave us the score that it gave us. And this can be quite handy as far as quickly giving us a direction into what we should be looking at. We can see a few things, the yellow ones, free physical memory, it's not so great. We had a situation where we were at 90% of physical memory that was used. We get an idea of what the overall maximum amount of memory is. It's giving us some general things like having, start warning us about swapping and running out of physical memory, which is nice. Here it's telling us a specific host and an amount of time doing I/O. So this can also be very, very useful, just with the note that, depending on the communication pattern, having large wait times depending on which type of communication that applications or protocol are doing could be completely normal. So just be aware of that. And we're going to open up a different JFR. Actually, we can obviously have multiple things open at the same time. One that I know quite deeply, let's just say it like that. So I know what I'm looking for. I know what's coming up here, and I know what I can show you. So here, this particular one, we've got a number of different scenarios that are immediately popping up as 100%. And this is actually one of the examples covered in the document. It's called example 1. We are seeing 75 points on the along socket IO, but principally we've got this high context switching and Java blocking threads for this particular keep alive cache, this monitor class sunnet www http keep alive class. So what's super interesting about this is we haven't done anything else than this, right? We just came in, we captured the recording, we came in here, we threw it in here, and we've already got some insights that we can use. And what I would recommend is to use this to guide your investigation from here. Look at these red areas. You can have a read of what the text is. It's not going to give you a whole lot of clarity, but it can give you an idea of maybe the types of things that you should be looking for. For example, longest record socket read took this amount of time. And then we can look at these icons over here in the outline view. Outline view under Java application, you can see we've got a number of the icons showing the different views. And we have this red critical warning for the particular area here, lock instances and socket IO. These are going to correlate to what we're seeing over here. Most blocking monitor class over here. This blocking Java blocking thread is relating to this one. The socket IO is relating to this one down here. So given that we have the Java blocking and context switches, I didn't read the application halts, but fine. It's these are all related. We're going to go over here to the lock instances. We're going to have a look at the lock instances first. It's just going to flip that back over to the stack trace view. And if we scroll to the top of the monitor class table here, maybe we can make this just a little bit bigger as well. There's a lot of information. It's quite densely packed on here, but we have a list of all the monitor classes that are defined, as well as a column that by default it's sorted by the total blocked time. And so I would typically, suggest sort by descending by blocked time, which is going to tell us how much time we've spent on the different monitor classes. And then, next look at the distinct threads. How many threads are implicated in being blocked for this particular monitor class? So here we can see we have 490 threads, overall 856 profiling samples in the recording, and this is the monitor class. Maybe one thing that's not being called out here, we are going to go have a quick look at, is this 856 samples. This is based on the approach that the profiling is doing. So if we look in here in the recording section, this is going to tell us the start and end time of the recording, as well as the overall recording time span. There is something a little bit strange about this recording, in that the time span is much greater than the mentioned duration here, and that's because of that ring buffer phenomenon that I was mentioning earlier. Is this recording was started, there's a fair amount of events that are being captured. You can see 700,000 events that are captured in the given time spans. So this is being essentially capped and cycled, likely based on the size. So it's quite short, right? So if we come back to this lock instances here, so this 856 samples means that in that 1.5 minutes, there are 856 profiling samples where this particular monitor class was blocking. With the settings of profiling type, this means that an event or an instance of a profiling sample for a monitor threshold is 10 milliseconds. So it's longer than 10 milliseconds. On the default settings, that's going to be 20 milliseconds. So let's continue looking at some of these things. So you can see all the different monitor addresses. This is the address that you would see in the thread dumps or stack traces, as far as who's using which monitor address. And similarly, we can use those columns in here to see the longest one. And we've got really this particular monitor address right here that is accounting for the largest amount of time here. 462 distinct threads over 6 hours. And now that I've clicked on this, I've essentially selected it, and it's showing me the threads that are implicated in this particular lock, and it's showing me the stack trace at the bottom. So looking at the stack trace, now that I have selected this, I can see my samples, number of samples, where this overall, this is like an aggregate view of the samples, 353 samples. 51% of the 0.7% of these samples are related to here, 51.5 related to here. In any case, we can see what this is relating to. It's relating to Azure. This is an Azure storage SDK blob upload. So we kind of already have an idea of what part of the application is being blocked by this. And the reason this is actually being blocked is that the default settings for this function in the SDK are to have 2 concurrent uploads at a time, and that's for concurrency management. That's a configurable value in the Java application, but the developer of this Java application didn't tune that particular setting. So this is why the the lock is having lock contention here. And I'm going to just quick flip over to the flame graph because this is giving us really that stack view so that we can understand how we got to here. Here we can't really see because there's just a thread run execution, but we see what it's doing. The flame graph is a little bit different. If we look at the flame graph view, this is actually an icicle graph because it's coming downward. The icicle graph, the bottoms here in the icicle graph, or if we switched it to a flame graph view like this, with the red one up here being the flame graph view, and then this is the icicle graph. Here it's showing us the tops or the plateaus. You can think about this as plateaus that we're looking at. The plateaus are essentially a given um, relative time period. So of this 1.5 minutes of our profiling session, this is, let's just call it 35% of the overall profiling session. Maybe this is 30 or 25%, and this is closer to 50%. Okay, if we go up to the top here, this 50% is split in two. But we can see where this keep alive cache, that monitor class that was blocking, we can see that it's being actually called across the 4 different places. So there are some separate paths that are leading us here to give us an idea of how we got here. But let's go back and I'm going to unselect. I'm going to try to unselect or maybe select everything. I'm going to select all of the monitor classes because that one was a kind of an easy one to find. Those two threads blocking are the main part of the performance contention here in this application. That let's say the top problem. But there are some other problems that are inherently latent in here. So by selecting all those other locks, what we're doing is now we're looking at a broader sample size. So this is all of the lock instances in that 1.5 minutes, which have a lock held duration over 10 milliseconds. So here we can see those cloud block blob guys coming up over here. We can also see them over here. Yeah, this isn't very exciting. This isn't very different than what I was just saying. But this is showing us that this is essentially all of the lock contention time is being spent here. So this makes sense, right? For that 6 hours and something. Maybe I'll just unselect this so that we don't have that one in the mix. And let's have another look at it again. Okay, so we do have some other things that are popping up here. Remember I said plateaus, like let's look for the plateaus. The width of the plateau is going to be the amount of time that we're spending in those sorts of things. And bottom is the heat map, right? Think of flame graph view. This is the execution, thread execution, all the way up through the execution until where the hot method. So this is the hot method. It's doing a zip file get entry, zipping files up. And then we can see there's some other things over here. Jar file get entry, so likely reading from a jar or something along those lines. Similarly over here. So you can see like very quickly, we're getting some ideas of where is the application getting stuck, where it's getting blocked. This could be related to file contention. We can see the code path. So we're starting to get an idea. We work with the developers. We can get an idea where we need to go look into fixing this. That might be configuration. It might be infrastructure, or maybe we have to make some code changes. So what else? Socket IO. So let's move away from the lock instances. Realize I'm kind of going quite quickly here through all this. Moving away from lock instances, looking at Socket IO, this is actually something that this particular client that I worked with, I found out some stuff about this Socket IO, which is freaking amazing. And it's kind of made this one of my favorite approaches for having a look at some of these types of performance because we can look at things over time and things like many different approaches. We're not going to capture a lot of things over time, like looking at thread dumps. You know, they're point in time snapshots, if you will. And that's not how JFR works. So here we are actually seeing the remote addresses. We're seeing the total IO time. We're seeing the remote ports. We can change this a little bit, combine those two together, or just look at ports first, followed by addresses. And I'm going to do the same thing. I want to see here the total I/O time. We're spending our time doing the socket I/O, and just kind of looking at this, we can see 8080 127.0.0.1. This is actually the same thing we were just looking at. It's another side of it. Upload file to Azure storage. The application is actually using a loopback connection to be able to send that file over to that Java application that's sending it up. And this is actually one of the ways that I stumbled across understanding this is by looking at this particular localhost address. We can understand the localhost address that's going to 8080. So we select the 8080 and the localhost address. Now we can see the overall stack that's calling us to get to this spot. And we can look at, kind of need to zoom in a little bit on this because the zoom to selected time range. Here we can see the socket reads that are building up over time. We've also got this durations tab, and this durations tab is extremely helpful because for the selected time range in the scenarios where I've selected the remote address and the remote port, it's telling us what the percentiles look like as far as the socket read times. So here we can see there's 285 profiling samples, which were all 20 milliseconds or below. But then when we get up to the 90th percentile here, we got 155 profiling samples that are 1 minute. 1 minute. It says 62 milliseconds, but they're just over the 1 minute, and they're curiously all just over the 1 minute. These ones are minute 12. There's one record, one sample that's over a minute 12. So that's quite curious. We can have a look at the event log and we can sort of have a look and come in here and see specifically which thread are making these socket IO operations. So I can use this to go back into the application to figure out what's being initiated from where. And I can see the overall duration. And this is quite indicative right here that we are hitting a timeout, right? A 60-second timeout where there's a timeout where something is calling something in the system. We're hitting a timeout. This is actually interesting that I've already got the timeout. This isn't default, but you can add visible columns here, and you can actually see when that socket read is being executed. There's a timeout that's configured on the socket read, and here you can see the timeout is 1 minute on the socket read. So this is actually the cause of why all of these HTTP requests are failing. And so just right there, quite interesting. If I flip over to one of these other more remote addresses, I'm not really sure what I did there. If I flip over to one of these other remote addresses, we can see a similar pattern as going to an outside system. But similarly, this is quite interesting because we see communications over HTTPS here, and we see some durations that are 30 seconds. We see some other that are 30 milliseconds. So that's a very significant difference in latency, and it's the kind of thing that's going to lead us to contention, to build up saturation and the like. And so I guess let's move on. I mean, let's have a quick look at, kind of scared to flip over to the thread view. I can't really look at the thread view in this particular one, can I? I'm going to have a quick look at the event browser. There's a lot of stuff in here. Maybe just going through some of the JVM internals real quick. Looking at JVM internals, this is going to tell us a lot of settings about the Java runtime environment, which once again, I mentioned things that you can't do on a production environment. A lot of times the people that are being asked to investigate something aren't going to have access to the production environment. Here, by collecting the JFR file, you can really see a lot of the JVM. Well, you can see the JVM flags. You can see the command line options that have been passed in. You can also see on this process view, there's a little CPU graph over here. zoom to selected range so we can see what the CPU utilization was. This is a process list over here. You can see the environment variables to check if there is a configuration mismatch between one environment and another. This is quite classic that we end up seeing that we expect to have a particular environment provisioned this way. But somebody potentially, triggered the automation in the wrong way or did some manual override, and then we end up with some parameters or configurations that aren't matching our expectation. Similarly with the Java properties. So I mean, I use all these to really compare the environment and looking at configurations. Number of times, I've used this to figure out we're using an incompatible version of a JDK. Down here, you can see this is actually a container compatible version, 11.0.16. And what else? What else? What else? Yeah, event browser. Event browser is really, I mentioned that these are a collection of events that are captured that are in here. Some of these nice views really do propose to us things that are quite relevant, but not everything is in here. So there are some things that you can do to have a look at things just by navigating in the hierarchy. You can use this search here. Looking at thread statistics, for example, in here is going to show us the number of accumulated threads, the total threads that have been created since the JVM started. You can see the active threads that are presently running at this particular interval. This is being captured every second. And the number of peak threads since the JVM has started. So this is super handy. Thread allocation stats, you can see the different allocations of threads. There's also some things about CPU. So there's thread CPU load, which can give us an idea of the CPU load of specific threads. We don't have a nice graph for it, but it's super handy. We can also look at some stats around thread starts. So here you can see just by searching in here for thread start, I've got 41,000 JFR events, which are all starting threads. That's a lot of threads to be created in a 1.5 minute interval. Here it's showing me what the name of those threads are. It's also showing me who the parent is. And if I click on one of them, then I've got obviously that flame graph view down here. I've also got the stack trace of it. So here we're starting to get to some really coherent things that I can use to understand what the application is doing and how it's running off the rails. Um, Spoiler that what I just showed you is about 465 or so thread creations per second, which is a lot. Um, and what else? Yeah, context switching. We did see that in the automated analysis, that context switching was kind of pegging 100%. That's related to those. So if I just search context switching here, we can see context switch rates. We don't have too many samples of the context switching. It's a little bit larger than those the event range that we're looking at, but you can see 17K, 7K, 18K, 16K hertz. So it's very variable. These are point in time captures, but this is giving us an idea that effectively, when we look closely at the context switching, because of the number of threads that are being created, it's quite huge. Um, Garbage collection activity. This particular system doesn't really have any GC type issues, but just having a look at some of the sections here, and this is one of the things that I like about it, is although the GC viewer is, I don't want to call it horrible, it's not very intuitive. It's got a lot of information that we can kind of slap together on here. You can see we've got the metaspace. It'll depend on the recording and what of data is in there, but we can add and remove some of the different metrics in here, include things like different phases, longest pause, sum of pauses here that are going to show the different kind of section in here to give us an idea of what the sum of pauses are. As you can see here, as I said, this is not really, doesn't really have GC issues. GC is running fine. We've also got the list of events here for the overall main causes of GC, and then here are the details in the pause phases, as well as some of the meta space stats. Lots of GC information. We've even got the configuration. So this is one of those situations sometimes where we wonder if we need to do some GC collector tuning. We can come in here, we can see what the collector is being used. We can see number of threads that are being used, what ratio, the GC time ratio is being spent. We can also see the min and max young size here. And we should have max heap, yeah, initial heap size, minimum heap size, max heap size. So we've got all of these settings in one place, and we can kind of come in here and just have a check at things to see if it's okay. I'll quickly use the GC summary all the time. It's pretty handy. Don't need to look at those fancy graphs and things like this. Just come in here, have a look at the GC summary. It'll give us a quick idea. There's been 6 young GCs in the minute and a half of the period. And the overall total, 6 GCs, average GC time, and max GC's time, total GC time. So it's going to sum these up for us, give us an idea of what our pause time is, how many GCs that there have been. So as I say, really fast way to just kind of get some quick ideas of what's going on. Don't think I have any TLAB information in here, but this is going to give us a thread local allocation buffer allocation. So telling us how the threads are allocating memory, whether they're inside of the thread local Eden space buffers, or if they're large memory spaces that need to be allocated in the overall heap outside of the thread local context, which is a little bit more expensive. And what else? There's one thing I didn't really show. I didn't show you the file IO. I don't believe there's any files in here, but it's similar to the socket IO, where if we do have any file operations that we're doing, then we can come in here, we can see what files are in question. We can have a look at what their overall performance is, and we can try to understand, something like logging. For example, if we have a contention from writing logs, this is something that we would see this show up in the lock instances for those locks to write the logs to disk, and then we would see it in the file IO where you've got long file write times. We didn't really look at memory, but this is going to give us, it's going to take some time to load, I guess. This is going to give us allocations from memory, depending on which settings we're using. It's going to give us the different classes, max live count, increases, percentage of overall. So similar to the other views, lots of details. And once again, where this differs from something like just looking at GC logs, logs are going to give us ideas about how the GC performance is running, and if there are large memory related things that are running, but it's not going to tell us what. Here we can use that stack trace and the flame graph, and we can look at the classes, and we can really get into what code is executing, how much memory is it using, and better understanding that overall. The threads, I think I really need to open another one. There's so many threads that are created. There's over 50,000 threads that were created in that particular example. So if I open the thread view, it's going to explode. And it will crash JMC. That thread view, if you've got thousands, tens of thousands, hundreds of thousands of threads, it will quickly hang JMC. So just be aware of that. This is a different example. We're going to use this to quickly have a look at memory and threading. So here, as I was mentioning, here you've got the different class. You can see the overall allocation sizes, the percentage of the total allocations, giving you an idea of the memory usage, the allocations over the time period, as well as the thread, the stack trace in question. And let's look at the threads here. So just a quick look at the thread view. It's super powerful. There's so much information in here. It's really hard to kind of compress it and get it all in here. But as we're kind of scrolling through here, you can see the lanes containing the different threads. and trying to pick something that might give us some form of indication we can kind of quickly have a look at. The different colors are indicating some activity that it's doing. And here you can see some compiler threads. So around this period, it's actually doing some compilations for some reason. And that could be, I'm not going to assume. I do want to see, this is perfect. So here you can see these event processor. This is a executor thread pool. We've got a number of threads. Most of the threads have nothing that are going on. They're parked. And then this one, it's got some pauses in here where nothing's happening. And then we're doing, red is essentially blocked. It's blocked on socket read. So here we can see the amount of time spent doing the socket reads. We're actually getting a remote host that's pointing to the database. Azure Postgres database on port 5432, timeout value 36 milliseconds. So, none of these reads are very long. So we know the reads data coming back from the database is quite fast, 56 milliseconds. But the fact that we keep going through this is indicative that, what we're looking at is some code that's running um, iteratively through some code. Let's just select the time period here for this particular thread, and I guess we can click on that big button here, and we can see that we're reading back from the PG stream. Prepared statement execute 98. So this is DAO layer connecting and communicating with the database. And here by looking at this, I know what this is. So I mean, we'd be able to find the code path and understand what queries are actually going back to the database. I've already selected that thread, so this is another way of looking at it using the flame graph. Um, Another way we can use this is just using this thread table. So if you right click kind of in this area around here, this is a little bit hidden. But if you get this pop-up, you can see I've got the show filter and show search enabled. I believe by default they're not displayed. So you kind of have to click around a little bit, throw that on there, and then it's a lot easier to just search for a particular group of threads or some threads that you have in question that you might want to go find, and that is going to pre-filter this section for us. You can see a little bit of, oh yes, because I've got this thread 3 is selected in this section. So once again, this can be quite dense in here. But here I have all of this thread pool selected over the given time frame. And you can also use this filtering capabilities up top here, combine with and add filter from attribute. So, you could use thread name. I typically use thread name that would say contain, but there's other things that you can do like duration. There's a thread duration. If you had a thread that started and stopped, you could use duration. You can use a method name, memory use. There's a whole bunch of things that you can essentially bring together, apply those filters, and it's going to filter the list of threads down for us. So that then we can kind of go into this thread view pane and have a deeper analysis of what we're looking at. One thing I should definitely call out is the selection. If I kind of make some selection like that and then I right click, here you've got zoom to selected range, store selection, store and set as focus selection. The zoom to selected range is really just a view that we're looking at in here. From what I've been able to figure out, documentation doesn't necessarily state that, but this is like what we're looking at now, and this is related to this orange bar at the bottom. This red bar at the top is what our focus and our aspect selections are presently set to, meaning that this is the entirety of the GFR recording. If I were to right click here and say store selection and set as focus selection, then here you can see that this red section up top is kind of bringing this in and is showing me now what I'm looking at is this particular, that's the zone of the time that I had selected specifically. And this is, it's kind of rendered the thread lanes a little bit strange. You can see it's actually called out just thread 9 here. And then from here, I have this focus that has been selected from the thread's timeline selection. And then the aspect is the number of selected events. And that's because I had selected that particular thread across those numbers of events. But now if I want to change this and kind of back out a little bit and just go to the interval, the time interval, or the event type, or the thread name, if I want to see all of the things for this particular thing, or if I want to see the duration, um, I want to see really selected range. So I want to see the time range. And now basically I've let go of that thread context, but I'm looking instead at the range of time that I had selected. And so, given that I have still this search text up here, it's giving me these particular threads for the time period that I have selected. So you can see now this little selector, which is the focus and aspect, which is essentially querying in on those JFR events, is giving me these results. And then this in the thread view now is showing me this orange selection, which matches here. Now, the interesting thing about that is that this top part is available all across JMC. So as I kind of understand what's going on and I want to focus in and I want to zoom in a little bit on one part of the analysis, then I can come over to one of the other sections and perhaps look at, say, Socket.io. We already saw that those were calls to the database. What do you know? Here's the database that's popping up. Um, but immediately, we get a stack trace across the board over a 1 minute, and we're going to see that same thing get asset list that was coming up previously. Um, So I think that's a pretty good quick view. I guess one thing I do want to flip into is let's have a look at this document that I've put together here as a next step. If you're interested, I mean, give this stuff a try. It's very very useful, and I've been using this internally for a couple of years with a lot of colleagues, technical support, R&D, incident management, et cetera, customers as well. Have a look at this document that I've written on the topic that's kind of dives into some of these concepts. It's a lengthy document to help kind of work your way through it. I've made a using this guide section as well as a quick start guide. So the quick start guide is really what we're just kind of going through right now. I've actually given you a deeper dive on JMC, but it's just a few things that you can do to get started doing a recording and starting to do some analysis right away. And then from here, I mean, I've broken the document down into a number of sections: flight recorder, command line, mission control, doing analysis, and then looking at a bunch of the sections of the analysis that we just had a look at, where we're going to go into a little bit of the explanations. And one of the things that I've tried to do is to bring some coherent scenarios in these sections. There's coherent scenarios that are like, how does that manifest in the real world? For monitors and locks, for example, database connection pool saturation or contention, where you don't have enough connections to the database and you're starting to see those locks appearing. That's the type of thing you can see in there. There's a whole bunch of scenarios that are outlined all throughout the document to give you some pause for reflection and investigation. And then later on in the document, you've got some real world examples. Example one is really a deeper dive on that one JFR recording that we were looking at previously, on how I got into really counting the numbers of threads and looking at thread creation time over time and breaking those down into different code paths from the application. Um, and some references. So there's obviously a lot of things from the internet that I kind of called upon to build this knowledge set over time, and I will put the links are in this document. This document will be linked in the video, and I hope that that others are as inspired about this as myself.